Good. So this question, let's read the introduction. The diagram not drawn to scale shows the positions of 3 points P, Q, and R on a horizontal plane. PQ is 120 km, PR is 150 km, and angle QPR is 23 degrees. The first question is calculate correct to one decimal place the distance QR. So guys, this is a non-right angle triangle. So you have to recall that you cannot use regular trigonometry, SOHCAHTOA here, right? We need to use either the sine rule or the cosine rule. Can anybody tell me which rule we'll use? Will we use the sine rule or the cosine rule for this one to find the distance QR? Anybody? Take a chance. What did you say, Fayed?
Cosine,
Cosine. Why would you use the cosine rule here?
because it has two sides and an angle in between.
That's right. Whenever you have two sides and the included angle, you use the cosine rule, right? So, of course, we want to find the side QR. So we need to use the cosine of 23 degrees, right? So the rule that we would use here, so using the cosine rule, and feel free to write the solutions with me or just completely follow along. But I want you all to be able to type this in on your calculator properly, right? So even if you're not writing, make sure you have your calculator and make sure that after class you write down the solutions to these questions and watch it over if you have to, right? So using the cosine rule, and also the cosine rule is given to you in your list of formulae. So you don't even have to memorize it, right? QR, the side that we are trying to find, QR squared will be equal to the sum of the squares of the other two sides, 120 squared plus 150 squared minus 2 times 150 times 120 by cos of the angle opposite this side that we're trying to find. So cos of 23 degrees. So therefore, QR squared will be equal to, okay, I don't have my calculator. I need to run downstairs quickly for it. But you all go ahead and work out this whole question for me because I think you all know how to do the cosine rule. I'll be right back.
After
Sorry, go
I
ahead.
put it in, but I don't know if my calculator thing. I don't know it not it have to be in degrees.
Yeah, correct.
Okay, I put it on degrees, but I don't know
Well, let's
why
work
it's
it out
saying
piece by piece, right? So 120 squared is what? Just work out what's 120 squared for me. What number did you get? You know how to do 120 squared on your calculator, love?
Miss. I can't remember.
Okay, well, there are two ways to do it. You could either press 120 and then press the key on your calculator that has X2, right? Or
Yeah.
120 squared literally means 120 times 120. So any one of those would give you the correct answer. So do any one of those and tell me what you get.
Oh, okay. I get Miss. I get one
What
four
is?
four zero
Yeah,
zero.
good. So 14,400. All right. Do 150 squared now.
Yeah, Miss. I get
What's
22500.
right? And now do 2 times 150 times 120
Miss, you say 2 times 150
times
times
120.
Times
Yeah.
120. Okay.
Yeah, because that's this part here. 2 by 150 by 120 in brackets. That literally means 2 times 150 times 120. What you get for that part?
Yes, no, miss.
Mm-hmm. Fire and Aaron or anybody else, if you all got the answers yet, just send it to me in the chat. Let me see. Just text it in the
Miss,
chat.
I get 36,000.
Right. So this would end up being 14,400 plus 22,500 minus 36,000 by cos of 23. Right? So then your next line now, we got to work that part out. So QR squared is equal to 14,400 plus, so 14,400 plus 22500. Check what that is. You check it, Misha.
Yeah.
What is
Miss,
it?
times what?
No. This part, we're working out this part here. 14,000 plus 14,400 plus 22500.
Yeah, okay. Yeah, miss. I get 36900.
Right. Good. So now we are at this point, which is 36,900 take away 36,000 by cos of 23 degrees. Right? So here what you're going to do now for me, Mish. You're going to type in this
Mm-hmm.
entire line, 36900 minus 36,000 cos 23 on your calculator. Right? So 36900
Yeah.
take away 36000 cos 23 and then press equal and tell me what you get there.
Miss, I get a long answer. I
Tell
get
me what it is.
3761.825276.
Perfect. Right? So let's just write this to four decimal places like that. And now, Misha, press your square root. So on your calculator, it looks like this.
Yeah,
This
miss.
key here. Right. Press that and press
Mm-hmm.
equal.
I get
That's the
61.3333720.
answer. Right? So therefore, if QR squared is equal to that number, then QR will be the square root of that. 3761.8253. So QR will be equal to 61.3 km taken to one decimal place because they told us to take it to one decimal place. And that's the answer, Misha. That's how you type it in on your calculator. That's how you do each of these steps.
Okay, miss.
You understand?
Yeah, I understand now.
Okay. Right. Everybody else, did you get 61.3 km?
Yeah.
Good
Oh,
job. All right. So the answer is 61.3 km to one decimal place, and that's 3 marks. All right. Now, the next question, the next part is to find the area of triangle PQR. All right. Now, typically, to find the area of a triangle, you need to use the formula base times height divided by 2. But in this triangle PQR, I do not have the base nor the height. So there is a formula that you can use to calculate the area of a triangle without having those two. And it's basically it's using the sign of the angle and the two included sides. And this formula is also given to you in your list of formulae, right? It's half of the product of the two sides multiplied by the sine of the included angle. Let me write that out to show you what it is. So the area would be equal to half of the product of the two sides. So half of 120 times 150 by sine of the included angle 23 degrees. I want every single person to type this into their calculators and tell me what it is. Maya, you will tell me the answer, please. What is the answer for the area of the triangle? Half times 120 times 150 by sine of 23.
Four 4,500.
Oh, I got something else. Try it again, huh? Try it again and see. Half times, yeah, what you got?
3,516.58.
That's correct. All right, we're taking this to one decimal place, so it could be 0.6, right? 3,516.6. And this is area, so it has to be kilometers squared, and this is taken to one decimal place. What you did wrong the first time, love?
Mr. put 30 instead of 23.
Ah, okay, got it. Good. So all the area of the triangle here will be 3,516.6, and there's its area. So area is square unit, so km squared. Right, so let me show you all how the bearings work now. All right, it says the bearing of P from Q is 252 degrees. P from Q. Guys, if it's from Q, where's the starting point? If it's P from Q, where's the starting point?
Q, miss.
Excellent. Q is the starting point, right? So they're telling us the bearing of P from Q is 252 degrees. In other words, that means this is point Q, which means that's the starting point, and this is point P. So if you're looking at the north line here at Q, all right, then the bearing of P from Q would be the angle formed between this line here, PQ, and that north line at Q. So this whole angle around here is 252 degrees. All right. And now they are asking us to find out what is the bearing of R from P. If it's the bearing of R from P, where is your starting point? Guys, yeah, what did you say? Somebody just said
P.
it. P, correct, right? So it means the starting point is at P, right? And the bearing of R from P would be this angle, this whole angle here, right? Between the north line at P and that line PR. All right. So let's see. There are a few things we could figure out here. So it's going to be this whole angle, right? So let me show you. I'm going to actually draw it separately because it's a lot going on in that diagram. So let's draw the diagram down here instead. So here's P. You have your north line there, right? And then you have Q over here. And you also have a north line there. You have your line connecting P to Q. And then you also have your line connecting P to R. This angle between here is 23 degrees. And then the angle on the outside here, this full angle here is 252 degrees. All right. So we want to know what is the bearing of R from P, which would be this entire, hold on, let me just make this line here a little bigger. Yeah, so we want to know what is the bearing of R from P, which is this big angle here, including this 23 degrees and over here. Right? So let me show you all guys why I showed you that thing just now about the two north lines being parallel to one another is in order to figure out what this whole angle is, right? From between the north line here at P and the line PR, I need to find out what this little piece inside here is. Because if I figure out what this little piece inside here is, I could figure out what the whole angle is because I'll just add this little piece to the 23 and that would make it up, right? So what you need to realize is that over here on this side, right, you have the angles around this point. This angle that makes up the whole rotation around this point. Can anybody tell me what is the number of degrees around a point? How many degrees do you have in a complete revolution? I didn't hear that.
360.
360 degrees. So the entire,
Internet sticking.
okay. So I'm breaking up. Okay, guys, hold on.
Miss,
I'm
I
gonna,
hear you.
okay. Anybody, are you not hearing me, guys? Or were you not hearing, fired, Aaron? Is it me or fired? Who were you
Miss, I
referring
hear
to?
you good. I didn't hear
Okay,
him properly. I
okay.
don't know if it's yours.
Okay. If anybody isn't hearing me properly, please say. But anyway, he told us just now that the angles around this point or the angles around any point is 360 degrees, right? So that would mean that the angles, this angle here that I just highlighted in red, plus this 252 degrees will be equal to 360 degrees. So that plus this unknown angle, let's just call it x for the while, is equal to 360 degrees. Can we then figure out what x would be equal to?
Yeah.
Yeah, how would we do it, Zach?
You want to get x alone, so you
Yeah.
take the 252 over the equal sign and minus
Mhm.
it from the 360.
That's right. If x plus 252 is equal to 360, then x will be 360 take away 252. Excellent. How much would that be, Zach?
108.
Yeah. X is equal to 360 take away 252. So x is 108 because 108 plus 252 makes up 360. So you see this angle over here, guys? This angle is equal to 108 degrees. All right. Now, the next thing that we knew about angles between a transversal and the two parallel lines, meaning this north line is parallel to the other north line. So oh wait, actually, let me draw it exactly how they're looking. So this north line here at P, right, is parallel to this north line at Q. All right. And these two angles, they are supplementary, meaning that they add up to each other. So this angle, which we just identified as 108 degrees, that plus whatever this angle is, will make up 180 degrees. So how much would this angle be, guys? If this plus this one is 108?
131.
No. 108 plus 131 is not 180. Is this one I'm talking about fired? The other angle that's supplementary to the 108 degrees.
72.
72.
72 degrees, right? So this angle here is 72 degrees, right? Because this plus the other one would give you 180 degrees because they are supplementary. All right. So now we know what that angle is. We can calculate the entire bearing of R from P, because the entire bearing from from P to R, whatever. R from P, sorry about that, would be this 72 degrees plus 23 degrees. So that bearing of R from P is equal to 72 plus 23, which will give me what? 72 plus 23 is what?
95.
95. And remember that if it's bearings, it has to be in 3 digits, right? I forgot for a second there. So it'll be 095. And this is a very common principle that is tested in the questions, right? So the first part, we had to use the cosine rule to determine the length, QR. Fire told us that it was useful, or it was easy to use the cosine rule because I would say recommended to use the cosine rule because it's an unknown side we're trying to find up when we are given two sides and the included angle. So we use the cosine rule for that. Then we use the formula, and Maya helped us to find the area using this rule, a half times the product of the given sides by the included angle. And then finally, we use what we know about bearings to figure out the bearing of R from P. So things that we needed to identify first, they gave us that the bearing of P from Q is 252 degrees. And Misha told us that if it's from Q, then we're looking at the angle between the north line at Q and the line PQ, the clockwise angle. So that was 252. And then we use that principle to figure out what the angle on the inside here was, because once you know what that angle is, you could figure out the angle here at between N and PQ over here, because this angle and this angle are supplementary since they are the two interior angles between the pair of parallel north lines and the transversal. All right, so it sounds like a lot just because I'm explaining literally every step of the way, but I'm recording this, guys, so please go back and look at it if you didn't quite get it. I'm gonna pause here for a moment. Right. The diagram below, not drawn to scale, shows positions of 3 ports, P, Q, and R. Q is 80 kilometers away from P. R is 100 kilometers from Q on a bearing of 66 degrees. And angle PQR is 54 degrees. Calculate the bearing of P from Q. Well, first of all, let us put in the bearing R from Q. Guys, if it's R from Q, where's the starting point?
U.
Q is the starting point, correct. So R from Q would be this angle. Well, they already have the north line at Q, right? And we already have the line connecting Q and R. So R from Q would be this angle here between the north line at Q and the line QR. So this angle is 66 degrees. All right. And now they want us, the first thing is to calculate the bearing of P from Q. Again, from Q, so we are starting at Q. Therefore, the bearing of P from Q would be the angle between the north line here at Q and the line connecting Q and P. Yeah, so that bearing of P from Q is this entire angle over here. Right? So therefore, the bearing of P from Q, well, you just have to add those two together. So it will be 66 plus 54. How much is that? How much is that, guys? 66 plus 54.
120.
120.
Yeah, 120. Perfect. Good. All right, so that is 120 degrees. Two marks, two easy marks. The next thing is to calculate the distance PR taken to two decimal places. Somebody tell me, are we using sine rule or cosine rule here?
Cosine.
Yeah, that's right. Aaron, tell me why. Why would you use the cosine rule? Aaron, where you going?
Uh, the items.
Tell me now. Why are we using the cosine rule?
Mm. Uh, the,
I will help you. I will help you. We're using the cosine rule because we need to find this unknown side that is, and we have two known sides and the included angle, right? So we have the angle 54 degrees and it's
side
between
we
the
have to
two known
know.
sides.
The side we have to know unknown.
What you said,
The
love?
side with the side here. I can't even write it.
Don't worry. I
Like
know what you
80
mean and
km.
I get it. Yeah, right? So we use any cosine rule because we are given two known sides and the included angle. So we'll start with PR because that's the side that we want to find. So PR squared is equal to the sum of the squares of the other two sides, 100 squared plus 80 squared, minus 2 times 100 times 80 by the cos of the angle opposite the PR, the side PR, which is 54 degrees. All right, so Amisha, me and you again, we're gonna work this out together. Everyone else, you can go ahead unless you want to take your time with me and Amisha. Misha there?
Yes, miss.
Let's go 100 squared. How much is that?
200, miss.
No, baby. 100 squared is 100 times 100.
Oh, shoot.
Small thing. That's happened. So 100 squared, 100 times 100.
Miss 10,000.
Yeah. What's 80 squared? Don't tell me, 160, yeah?
No, 6,400.
Right, right. And then minus 2 times 100 times 80.
That's not miss.
Mhm.
Wait, basic, repeat that.
This part, we're working out this part now. 2 times 100 times 80.
Oh, okay. City 6,000.
I feel you multiply 2 twice because it'll actually be 16,000.
Oh.
Yeah, I
Oh,
feel
yes,
correct.
miss. My
Yeah,
bad.
right? By cos of 54 degrees. Okay, so then the next line is we're gonna work out this whole thing. Type in this whole thing in your calculator here. 1,000 plus 6,400 minus 16,000. And tell me what you get. It'll be a big number.
Yeah, miss.
That's not a miss.
Yeah,
Oh,
sure.
Miss, but
it's off
right
the
now I
shape.
have on nails and it's giving me trouble to press the button.
Well, that means I gotta take off your nails.
I get
What did you say,
miss.
Aaron? One second, Amish. Aaron, you said something?
I oh if she
Yeah,
get the
miss, again.
answer. How did the
Okay.
answer so?
All right, what you got?
I get 6,995.435963.
Right, Aaron, you get that?
Yeah, yeah.
Right. Good. Now, Amisha, just press the square root of that. Just
Mm-hmm.
press the square root and press equal and tell me what you get.
83.63872287.
Perfect. And they told us to give our answer to 2 decimal places. So the answer will be, hold on, I just want to write this in so you get the full solution. Right. So the answer will be PR is equal to 83.64. Right? Because it's 83.638. So since the third decimal place is greater than 5, we will add 1 to the second decimal place, making that 83.64 km to 2 dp.
Yes, miss.
So this would be, the answer is 83.64 km. Let me do a check. Tristan, how we going there?
Miss, I think something wrong with my calculator.
Oh, shucks, tell me. What
I
happened?
get I put in everything and I double check it,
Mm-hmm.
and I get for PR squared, I
Uh-huh.
get 15,15459.5.
All right. Well, maybe let me check it too. Maybe we made a mistake. Let's see. All right. So 100 square. I'm gonna actually type in this full first line, and maybe you could try it too with me, Tristan. Let's type in this full thing, right? 100 squared, and use the abbreviations, right? So use the shortcut for squared. 100 squared plus 80 squared minus 2 times 100 times 80 by cos of 54. Oh, I still got this, Tristan. 6995. Tell me. Tell me if you get it.
I put in it, miss. I get something different again.
Is your calculator in degrees?
Yeah, miss.
I don't know why. Everybody else, did you all get this? 6995.435963. Fired.
Yes,
Yeah, you got that?
yes.
Listen, I feel something might be wrong with your calculator. For real? You want to type it in one more time and see, honey?
Yeah, miss.
I know, and tell me.
Yeah.
But yes, guys, I think this is the answer. 83.64 km. All right, I was checking in the meantime while Tristan does it. Maya, how you going there, honey? Hey, Maya, you guys in true love? Oh,
Yep.
okay, good, good. Zachy boy. Your Zach's name on Instagram is Zachy boy. That's why I call him Zachy boy. Zach, are you getting through? Hey, where's Zach gone? Paige and Zach. Tristan, you got through now?
Yeah, miss. I feel I was typing it in wrong. I get back.
Good, perfect. Wonderful. Okay. And well, Aaron, I know you guessing true because you tell me you get the answer, right?
Yeah, miss.
Good. So then the next question, the next part of the question is to calculate the measure of the angle QPR to the nearest degree. Okay. Angle QPR to the nearest degree. Which angle is that? QPR. Okay, this angle over here. We need to find this angle. All right. So we can use the sine rule. You can use the sine rule or you can use the cosine rule because now we know that this side PR, we know that this side is 83.64 km. And if you're using the cosine rule, you can to use the cosine rule to find an unknown angle, you have to have all three sides, which we do have in this case. To use the sine rule, you really just need two sides and any angle. So let's go ahead and use the sine rule because we've been using the cosine rule all along, right? So using the sine rule, we need to find this angle QPR, which is this angle over here. So using sine rule, all right, the side opposite P, right, which is 100 km, over the angle, the sine of angle P is equal to, let's use this, well, we could only use this angle anyway, Q and the side opposite Q. So that would be 83.64, which is what we calculated, over the sine of angle Q, which is 54 degrees. All right, and I don't know if you all remember the sine rule, but you got to cross multiply here. So sine P times this would be 83.64 multiplied by sine P is equal to 100 times sine of 54, right? Now we could work that out, right? We could say that, so this would mean that sine of 83.64 sine of P is equal to 100 sine 54 is 80.901699. When you're working out when you're doing your calculations, try to use as many decimal places in the calculations itself and only approximate at the end, right? This would give you the closest approximation to the answer. Okay, so then if 83.64 sine P is equal to that, then sine P is equal to 80.901699, all divided by 83.64. So therefore, as with any trigonometric ratio, well, any Trigs question, I should say, to find the angle, you have to use the inverse functions. So this will be sine inverse of that. So you could just, right, so this would be, let me divide this. So 80.901699 divided by 83.64 is 0.96726, and therefore P is equal to the sine inverse of that, which would give me 75.3 degrees. Yeah, 75.3. I said 3 and somehow Siri thought I said Siri. So that's the answer, guys. Tell me if you got it. If you want me to go through it with you again, 75.3. Make sure you all are doing, oh, sorry. It says to the nearest
Yeah, Miss, I
degree,
get
guys.
you.
Ah, good job. It says to the nearest degree, so this will be 75 degrees, right? Because it says to the nearest degree, so nearest whole number. The answer is 75 degrees. Good job, Aaron. Everybody else, tell me, if when you were doing it,
Thanks, Miss.
make sure you are doing, you're welcome, love. Make sure you are doing the calculations with me because I want you to get accustomed using your calculators for this. Okay, I'm seeing a message. Okay. All right, so you're gonna take a little pause here. Right, let's go. What will be the next line?
Next line would be 81
Mhm.
plus 144
Yeah.
minus 261 cos 60.
216.
Oh, yeah, miss, sorry.
Yeah. Cos 60, right?
Excuse me, Miss.
Yeah.
you could make the screen bigger. Well, not bigger. Well, zoom out or take out a picture and just finish off the rest,
Oh, okay, sure. 1 second.
if you don't mind.
No, I don't mind
Yeah,
at
miss.
all.
Okay, miss.
Is this good enough?
Yeah, miss.
Tell me when you got it, okay?
Thank you, miss. Yeah.
You're welcome. All right, Tristan, let's go. Me and you again. Yeah. Third line.
The third line would be 225 minus
Mhm.
216
All right.
and that would be 9 cos 60.
No, babe, you can't work out this part like
Oh,
that,
oh,
right? Because 216 cos of 60, that's one whole thing. 216 is like, you know how like you could have 3x, like you could have 5 plus 3x, and
yes.
this would just be 5 plus 3x. You cannot add 5 to 3 because 3 is the coefficient of x. It comes as though 216 is the coefficient of cos 60, right? So 216 is part of that whole term. So you'd actually have to do 225, take away 216 times cos of 60.
Oh, okay. Yes.
Yeah. So this doesn't work out separately. It'll be 225, take away 216 multiplied by cos of 60. This is one term by itself. Everybody, that's something to note, huh? This is one term by itself.
Well,
Okay?
the next line would be 17.37.
Okay. So did
So
you
that's
do 225 take away 216 cos of 60?
yeah.
And you didn't get 117?
No.
Try again. Do 225 take away 216 cos 60. And tell me if you get 117.
I get back the same thing.
All right, scratch it. And all you're typing 225 minus 216 cos 60. Exactly as it is written here. No extra multiplication signs, no extra any signs. Just 225 take away 216 cos 60.
Yes, I get 117.
Right. So then QS will be the square root of that, right? And take it to one decimal place and tell me what the answer is.
I get 10.8.
Excellent. 10.8 is the answer. Aaron, you got 10.8?
Yeah, miss.
Excellent work. 10.8 is correct. Okay, let's look at the second part, which is, oh, I was really supposed to write this solution in this area here, but I wanted us to be able to see the diagram. The next one is the measure of angle QTS. So let's see where that angle
If I
is.
could do this one.
Of course, let's do it together. QTS is this angle over here. All right, tell me what you did.
Yeah, miss. Wait,
All
what are
right.
you working on your answer?
Tell me what rule you use.
What rule I use? Sin.
All right,
Sign
use the
or
sign. Yeah,
sin
yeah,
or
sign
sign.
rule. Perfect. Okay, so
Yeah.
let's walk me through it, right? Because I want the others to hear the explanation too. All right, so what you did?
So I take 10.8
Yeah,
by sin 40 degrees over 13.
uh-huh. So, all right, let me just write this quickly before
Right, and
you hold on just now, Aaron. 1 second. Let me just write in some vital parts here. So you need to make sure you say you're using the sign rule to start your solution, right? So that we know that that's the rule that you're using. So using the sign rule, and I should have actually wrote using cosine rule up here. Just so that you let your marker know which rule you're using. Otherwise, then these things would just be arbitrary, right? So you have to say what rule you're using. So using the sine rule, 10.8 over sine of t would be equal to, oh wait, I prefer to write this over here instead, sorry. 10.8 over sine of angle t, which is the angle we're trying to find there, is equal to 13 over sine of,
1040.
yeah, good. All right. And then what?
Right now it's 10.8 by sin 40 over 13.
Yes, that's correct. Good. So I'm gonna write one line in between that, right? So I'll write 13 by sine of t is equal to 10.8 by sine of 40. So then sine of t is equal to 10.8 sine of 40 divided by 13. Good. So now I'm up to speed with you. Okay. Now what?
And then 10.8
Oh, I think I lost you.
by 0.6428 over 13.
Oh, okay. All right. So
Listeners,
so you worked it out. Okay, and then what you get when you work it out? 10.8 sine 40 divided by 13. What you got when you work
yes,
that out?
wait,
I'm
if you
hearing
get me
you.
some,
I'm hearing you, but I feel
I
like you
got
can't hear me.
0.539,
Yes.
0.534.
Yes. 0.534 uh 008. Yeah. Yeah, good. So then
And then you think it and you get 32.3 and it's 32 degrees.
excellent. So then you do the sine inverse of that. So sine inverse of
Yeah.
0.534008, which will give me 32.3 degrees. Yeah,
Yes, 32.3.
excellent. Good job. And this is taken to one decimal place. Excellent work, Aaron. I hope everybody else is following. If you're not following, please let me know.
MS, thanks.
You could either tell me right here, big and bold and brave, because there's no reason not to, or if you're really feeling shy, text me, okay? Either send it directly as a chat, as a message directly to me on the chat, or let me know on WhatsApp. All right, and then we still have two more parts. This question is to find the area of triangle QRS. QRS, Zach, are you there? QRS.
Yeah, miss.
Zach, I want you to help me find the area of triangle QRS. Do you remember the formula to find the area of QRS?
Isn't it half of something? Half of
Yeah,
the area?
half of AB times sine C, meaning half of the given side multiplied by the known angle, right? So I'm gonna just draw the triangle down here so I don't have to like keep scrolling up, right? So we have the
Yeah.
triangle. This is the triangle basically. This angle, it's what is it? 9, 12, and 60. Okay, so here is 9. Here is 12 degrees. And this is 60. Or is it the opposite? Oops, I made a mistake. 60 is the angle. Right. This angle is 60 degrees, and then this side is 12. Yeah, okay. And it's in meters. Okay. Right, Zach. So
Okay.
you don't have to memorize the formula, so I'm not even testing you on that. The formula is given to you. The formula is half the area is equal to half of the product of the two given sides, which is 9 and 12. So half of 9 times 12 by sine of the included angle.
60.
Yeah. So work that out for me, love.
Give me 1 second.
Yeah.
Oh, I get 0.000.
Nah, you do something
No,
wrong. Either your calculator is in radians or you use sine inverse or something.
wait, let me try again.
Yeah.
I still got 0.00.
Are you sure your calculator not in radians?
Is in degrees.
All right. All right, let's do this together. Type half. You type half,
Type 1/2, yeah,
right? Multiply
by 9.
9 times 12 times sine 60.
I got 46.8.
Yes, that's the
One decimal
correct
place.
answer. All right, so I don't know what you did before, but this is the correct answer here.
I put 1 divided by 2 instead of 1
Okay,
over 3.
okay. I mean,
Is that a
that shouldn't give you the wrong answer. But, or you know what? It might because it would give you, the calculator would use BODMAS and it
yeah.
would work out no, it should still work out, because it still is multiplication and then division. So it should still work out. So maybe whatever happened. Now you get the correct answer. All right. Now for the last question, the perpendicular distance from Q to RS. And guys, this is only 1 mark. So this is only 1 mark. You have to know that it can't be no big, long kind of working. The perpendicular distance from Q to RS. So let's go back to our diagram. Oh, where did it go? Yeah. Right. Q to RS. The perpendicular distance, people, means this. Right? It means like if you drop a straight line from the point Q to RS. All right, so that we can use Pythagoras' theorem. Or you could just use a trig ratio, actually. Yeah, you could use a trig ratio because you can't use Pythagoras' theorem there because we don't know if this is not an isosceles triangle. If it was an isosceles triangle, then the perpendicular line, the line from Q to RS, which forms a right angle, it would have divided this RS into 2 equal halves if it was an isosceles triangle. But QRS is not an isosceles triangle. So that means we'll have to use the SOHCAHTOA. Right? So you'll have a right angle triangle here. Y'all remember SOHCAHTOA? Anybody remember SOHCAHTOA?
Yeah.
Right? So we would have to use, let's see. They give us the hypotenuse. This is the hypotenuse, and we need to find the opposite side. Which ratio uses opposites and hypotenuse?
Sine.
Sine. Yep. So it will be sine of 60 is equal to the opposite over the hypotenuse, right? So let's write that in. Hold on. Good. So it's the same it's a triangle, so I'm drawing it in here, right? And this side is 9 meters, and this angle here is 60 degrees. And we need to find this side here. Let's call it x, right? So using sine, sine theta equals opposite over hypotenuse. Sine of 60 is equal to x, the side we're trying to find, over the hypotenuse, which is 9. So therefore, x is equal to 9 times sine of 60 degrees, which would be equal to 9 times sine of 60 is 7.8. And this is taken to 1 decimal place. All right. Right. The diagram below, not drawn to scale, shows a vertical tower BT with a flagpole TP mounted on it. A point R is on the same horizontal ground as B, such that RB is 60 meters and the angles of elevation of T and P from R are 35 degrees and 42 degrees respectively. Label the diagram label the diagram to show the distance 60 meters, the angles of 35 degrees and 42 degrees, and any right angle. Okay? Well, first things first, the easiest thing to label there is the 60 meters. RB is 60 meters. So this is B and this is R. So that distance RB is 60 meters. Here is 60 meters. Of course, this is the right angle. All right. And then it says the angle of elevation of T from P, sorry, T and P from R are 35 and 42 respectively. So T from R, this is R here. Remember your angle of elevation is between the horizontal and the line connecting R to T. Good. So this angle here in the middle, this angle, this little one here, is 35 degrees. Angle of elevation is formed between the horizontal at the starting point and the line of sight, the line connecting R to T. And therefore, the angle of elevation of P from R would again be the angle formed between the horizontal here at R and the line connecting P to R. So that's the bigger one on the outside, right? So that would be this angle over here. That big angle is 42 degrees. And this is how you will get your 3 marks. 3 easy marks, I would say. Now they want us to
I can do the
calculate
next one.
the length of the flagpole.
Yeah.
Yeah, you could try it for sure. Or you mean you want to do it with me, like verbally, or you're gonna do it like silently and I'll do it with the others?
No,
What you
I'll go ahead and get the answer and everything.
Oh, I got the answer. Okay, what was the
Yeah.
answer?
So I use Stanford.
Yeah, yeah.
So it's 60 by tan 35 degrees,
Mm-hmm.
and I get 6 by 0.7002 equals 42 meters,
Okay.
right? And then that is for the 35 degrees. For the 42 degrees, 60 by 0.9004, I get 54 meters.
All right.
And I take 54, take away 42, and I get 12.
All right.
So
Well,
it's 12 approximately meter long.
okay. I think it sounds good. Let me work it out now and see. Excellent work, Aaron. So, in order to find the length of the flagpole, we would first need to find out what is the entire length BP, right? Because you know there are two triangles here. There's this big triangle, BPR, and you could find out what's the length of BP. And then you can use the smaller triangle, BRT, to find out what's the length BT. And you subtract the length BT from BP, and you will get the length of the flagpole, because the length of the flagpole is the difference between PB and TB. All right. So let me just take out the two triangles to show you all it's individually, right? So let's look at BTR first. All right, let's pretend this is BTR. BTR. So that's the angle of elevation. We're looking at the angle of elevation of T from R. So this angle here is 35 degrees. It's a right angle triangle. And this side is 60 meters, right? So to find TB, we'll use, let's see, TB is the opposite side. TB is the opposite side, and we have the adjacent. So like Aaron rightfully said, good job, Aaron, we'll use tan, right? So tan of 35 degrees is equal to the opposite side, which is TB, over the adjacent side, which is 60 meters. So therefore, TB is equal to 60 times tan of 35, which is equal to 60 tan 35 is 42 meters. And then the bigger triangle is BPBR. So that would be PBR, and that angle is what was it? 42 degrees. This side is still 60 meters, so it's the exact same working, except you're using tan of 42 instead. So tan of 42 degrees is equal to PB over 60. So therefore, PB is equal to 60 by tan of 42, which is 54. Right? So therefore, the flagpole, which is the difference of those two, the length of the flagpole would be equal to 54, take away 42, which is 12 meters. Aaron, great work.
Thanks.
Good, so that's 4 marks, guys. All right. Guys,